What's going on, everyone? You're back with your boy Jono for another quick math lesson. Today we're going to look at the volume of a sphere. And luckily for you, we're not looking at how to prove the formula. We're just looking at how can we use it effectively to get marks in an exam. So we've got two formulas about spheres. The surface area is 4 multiplied by pi multiplied by r squared, or the area of a circle multiplied by 4. And then if we look at the volume of the sphere, it gets a little bit more confusing. We've got 4 over 3, which is a weird number, multiplied by pi r cubed instead of squared. So this formula is harder to remember. There's more stuff going on, but I've got a little trick on how I remember it at least, so I don't make a mistake in an exam condition. So the way that I remember both of these formulas is I start with this area of a circle, so pi r squared. And then to find out the surface area of a sphere, we've got to multiply the whole thing by 4. So now we're at 4 multiplied by pi r squared. That's our surface area. But because we're looking at volume, instead of having a number squared or r squared, it makes more sense to have a number cubed because we're going to have a unit of cubic centimeters, cubic meters. So I'm actually going to change that r squared into an r cubed. But I like to think about it, making that power go from squared to cubed takes a lot of effort out of our equation. And for that reason, we've got to take some stuff from the front. So instead, I've got to divide that front number, the 4, by the power that we used it, which is 3. So I know that's pretty silly. You can just remember the formula if you want, but that's how I remember it. It starts with the formula of a circle, pi r squared, multiplied by 4 gives you the surface area. Increasing it to volume takes it from a squared to a cubed, and divide the front number by 3. You might not have to remember it, you might get given the formulas in an exam, but you never know, it could come in handy. So we're just going to look at an example here. We've got to find the volume of this sphere. And I know that this is just a circle. I tried so hard to make a sphere on this whiteboard and it was not happening. So this is the best we can do. So all I've got to do is chuck in the numbers into the formula to get the right answer. Before we get started, I do just want to flag that the numbers get really big really quickly. Because the radius is cubed and not squared, some of the numbers you'll get might seem too big, but that's not an issue. They just get big quickly. That is correct, but it means your guess might not be correct to start off. So this is just 4 over 3 multiplied by pi multiplied by 12 cubed. So if you type that in your calculator, you get the answer of 7,238.23 centimeters cubed, and then you're done. So that number is way bigger than the surface area of a cube or even the area of a circle, but that's fine because we are cubing the radius, not squaring. And so for this one, we're going to work backwards. We've been given the volume and we've got to work out what the radius is in order to give this as an answer. Just before we get started, that last example had a radius of 12 and we got an answer of 7,000. So we know that this number, the radius, is going to be much smaller than 12. So if you get a weird answer and you're like, oh, that's a really small number, you might be on the right track because again, these get quick fast. So for this, all you've got to write is that I've got 1,024 is equal to 4 over 3 multiplied by pi multiplied by r cubed. So that means I can divide off the 4 over 3 multiplied by pi to get r cubed by itself. So that's r cubed is equal to 1024 divided by 4 over 3 times pi. Throw that into your calculator and then we've got to find r by itself. All you've got to do is use the cube root of the answer that you got just before. Try not to round in this step because it might make your answer off by a few decimal places, which would be a really silly way to lose a mark. You can just use the answer from your calculator from the step before. If you do just want to do it in one step and put cube root over the fraction, that's totally fine, but I'm just breaking it down so you can see exactly what I'm trying to do. Once I throw this in my calculator, I get the answer of 6.25. That's right on track. I said that 12 was way too big of an answer, so 6.25 absolutely makes sense. You could chuck it in, substitute it back in order to check that we got it right, but I'm very confident that this is on the right track. Thanks so much for watching this lesson, guys, and I'll see you later.